Hello dear student, how are you? Hope doing well at home. In the last video number 1, we have learned about the magnetic effect of electric current. In this topic, we had learned about the three basic concepts. The first, Auster experiment. Second, that is Biot-Savart's law. Third is application of Biot-Savart's law. Today dear student, we are going to learn about how to find out the strength of magnetic field due to different shapes. You might be remembering in the last video lecture I had given you the three basic formulas. That is, first, when current is passing through any wire or the coil I, the strength of magnetic field, its magnitude can be written as mu naught Ni upon 2A. Second, we had learned about when current is passing through any wire but the point is along the axis from the element dl at a distance r. A is the radius, here also A is the radius, x is the distance of the point P from the center O. The formula was how to find out the magnetic field, the strength of magnetic field at point P due to the small element dl and the current passing through this circular wire I. B is equal to mu naught Ni into A square upon 2 times of A square plus x square raised to 3 by 2. The third was due to infinitely long conductor at a distance A, if you want to calculate the strength of magnetic field, the formula was B is equal to mu naught upon 4 pi, it is I upon A into sine of theta 1 plus sine of theta 2. Now on the basis of these three formulas, today our topic is how to find out the strength of magnetic field due to any sheet. So let us learn about that. Now first, you might be remembering in the first video lecture I had given you the concepts of 3D imagination with respect to x, y and the z axis and I cap, j cap and the k cap unit vectors along them. Now dear student, for JEE, NEET or MSCT point of view, this is very important to note. Sometimes in MCQs from the section magnetic effect of electric current, they are asking in terms of magnitude or sometimes they are asking in terms of what the IJK, the direction they are giving the respect. So in that case are the concept what I had given you, the concept of 3D imagination, so that will be very helpful. Now, so let us see, suppose today our topic is shape the magnetic field. Now in this case, suppose your first topic I am taking, the shape of the wire is like this. Now in this case, suppose O is the center of this semicircular wire, this is the straight wire, this is also straight part, and let us say A be the radius of this semicircular part. From this particular shape, let us imagine I is the current which is passing. Now in this case, what we have to do to find out the strength, because as you know, current is passing through this straight wire also, this part also and the semicircular part also. So we have to divide this entire shape into 3 parts. Then this part is going to produce a magnetic field at point O, semicircular at point O, and this third part is also going to produce a magnetic field at point O. So total magnetic field we imagine like this, B1 plus B2 plus B3. But dear student, you remember, due to this straight part the point O is along, okay, it is on the wire. For the third part also, the point O is on the wire. So if the point O is on the wire, the angle, that is theta 1 and theta 2, that we have to consider 0, and in that case the sine 0 is 0, and we will be getting the total magnetic field due to part 1 and part 3 is equal to 0. So we would left with, that is 0 plus B2 plus 0. So the total magnetic field we need to calculate only due to the part, that is B2 part. Okay, now that is the second part. If I consider this part, and this part is going to produce a magnetic field at point O. So the formula is B2, which is equal to mu naught Ni upon what 2A. But dear student, this formula is for the full circle. What I need to do is, as it is a semicircle, I will divide this, okay, now as a half. So the B2 का strength will become mu naught Ni upon what, the 4A. So this is the total magnetic field due to the semicircular part. So the total magnetic field due to the entire shape would be B is equal to mu naught Ni upon what, the 4A. Now let us come to the 3D imagination. Suppose I want to resolve this in terms of what, IJK, or with respect to direction. You know, dear student, here we apply the right hand rule. As you know, if the thumb indicates the direction of current, the curved finger indicates the direction of what, the magnetic field, if I hold a straight part. Now exactly vice versa for this. Now if the current is passing in this manner, just like circular part is like this. So if the current is passing in circular manner, the magnetic field would be in the straight way, and that magnetic field will be inside the plane of this board, you can consider. So the direction of B2 is inside the board. Now if I resolve this with respect to x, y and the z axis, is it clear? Suppose like this. So this part, okay, now B2 is inside. So if I consider this as x on, this is x axis, y axis and what, the z axis, and with respect to I cap, j cap and the k cap, they are the unit vectors along x, y and the z axis. Now if I consider this point O as the origin over here, and okay, now the semicircular part is passing like this, okay, semicircular part is passing like this. Suppose in this case, this is the situation, okay, this is the situation. In this case, the current is coming like this from here, the current passing through this semicircular part and going from here. Now in this case, you look, the strength of the magnetic field what, inside the, okay, now plane. So here in this case, the vector which is opposite to what, k cap, is what, the minus of k cap. Now you can look very easily if you resolve this, okay, now this shape with respect to x, y and the z axis, the B2 ka direction, the strength of magnetic field due to this semicircular part is inside the plane, and you can look here also, it is along the minus of k direction. So with respect to, if I want to resolve this in terms of vector form, so it is what, k cap, but it will be a minus. Why it is minus? Because it is opposite to what, k cap, and here we have to write down what, the vector form. So we have learned here how to resolve the vectors, how to find out the magnetic field, and how to divide the shape into number of the parts. You can note it down. I am giving you just a fraction of seconds to note it down this. So in the second shape we are going to take, second shape, suppose I am taking like this. This is, we have learned, and here I am drawing in one more semicircle. Now let us imagine the current is passing in this direction from here, here, here. So from this part the current direction will be exactly reverse for this. Now in this case there will be naturally, that is we have to consider the two radius. This is R1 and this is R2. Remember R2 is greater than what the R1, so B2 का strength will be less than what the B1, as B and R they are inversely proportional. Now dear student, this is the point O. So how many parts you look over here? So I look, suppose this is the part 1, the part first, second, third, and this entire bigger semicircle is a fourth part. So total magnetic field will be the magnitude of that magnetic field. I am not taking vector consideration. It is B1, B2, B3 plus B4. Now in the last shape we have learned for this part, part number 1 and part number 3, part number 1 and part number 3, the magnetic field would be 0. So B is equal to, we would left with P2 plus what the B4, sorry. So we need to concentrate only on the two shapes, that is of radius R1 and radius what the R2, as they are what the semicircle. And in the last shape only we have learned about the formula mu naught Ni. You know why I am writing N? Because sometimes in MCQs they are asking with respect to what the, if they are increasing the number of turns of the coil. So we have to take naturally along with that formula mu naught Ni upon what the 2A. So the formula was the 4A. The formula was 4A. In the last shape only we have learned about the same for the semicircle, because 2A is for the full circle, and if we divide that into, that is what the half section, then the formula is coming 4A. Okay. So find mu naught Ni upon what the 4A is the formula. So there will be B2 and the B4. So in that case, suppose this A is the radius. So here in the numerical, in the MCQ it is given R1 and the R2. So naturally we will substitute B is equal to mu naught Ni upon what the 4A. So 4 times of R2 plus mu naught Ni, because current is the same in both the cases. Okay. Mu naught Ni upon what you are there, 4 times of R4. Okay, fourth part. So here the radius is R2, so I will be taking what the R2, and this is R1, so I will be taking what the R1. Okay, so fine, it is the formula. Now this formula is not the correct, because it is we have not considered here the who is greater and positive and the negative with respect to IJK. Remember, again we will go toward the 3D imagination. This part, okay, now this second part, the current direction is like this. The current is flowing in this manner. So the strength of magnetic field, or the direction of the magnitude of the direction of the magnetic field inside the core. So I'll be writing a drawing like this for you. Okay, now so this will indicate inside, so it is B2 bar. Okay, now in this case if you see this particular shape, the current is flowing in this manner, the current is going in this manner. Okay, now for the fourth part, so where will be the direction of magnetic field? So this is the direction of magnetic field. So according to that, so the strength of magnetic field, the direction of magnetic field is what B4, but it is opposite to what you are B2 bar. So B4 and B2, they are opposite. So I'll modify this formula. Okay, now how to modify? Just look at this. Now, but remember here, who is greater? Whether B2 is greater or B4 is greater. The strength, the magnitude of the magnetic field, B1, the B1, or that is this part is producing what the magnetic field B2. So for B2, this is the B2 is the, okay, now B2 is the magnetic field over here. So the strength of magnetic field, because B is inversely proportional toward the radius. So this radius is smaller. Okay, this radius is smaller. So this R2 would be what? Okay, now R2, this radius is bigger, so the strength of this magnetic field B4 is greater, and strength of this magnetic field, okay, now this R2 is bigger, so magnetic field is what? The less. So B2 is less and B2 is B4 is less and B2 is what? The greater. So in this case we will say the formula will modify as what? The minus sign. And remember here, if we resolve, so this vector is coming along what? Your the k direction. So we will be writing more what? The k cap over here also, and here is also the k cap. But this k cap is positive and this k cap is what? The negative. Is it clear? This okay, now according to this direction, okay, B2 bar is inside, okay, now B2 bar is inside and B4 is what? The outside. So if I consider this particular, okay, now so this particular shape, so B4 is what? Your the outside and B2 is what? The inside. Okay, so B2 is inside, okay, so this will become what? The minus, and B4 will become what? The plus. So dear student, in this manner we have to consider the direction of magnetic field as well as what? Your the IJK vector resolution. Okay, now so please note it down this. Now dear student, we will be going for one particular shape, and this third part is very important. In 10th standard we have learned about the arc of the circle. Now if you imagine the part of the circle, from one particular part the current passing is what? The I, and you want to find out the magnetic field. So if this is the arc of the circle of its sense, so complete the sense with respect to what? O. So because this is the part of a circle, so naturally it has some radius R as well as what? The center O. But in our formula we are taking this R as what? The A. Now this particular length or this particular shape is making an angle theta with respect to, okay, now so this part, according to Biot-Savart's law, the formula is B is equal to mu naught upon 4 pi I dl sin theta upon r square. Remember dear student, this theta is not this theta. Okay, why? If I consider a very small element dl from this section, so it makes an angle theta which is equal to what? 90 degree with respect to O if radius is what? The A. If this part is infinitesimally small, so this theta will become equal to 90 degree. So if I substitute here, so formula will be B is equal to mu naught upon 4 pi, it is I dl upon what? The r square. Now here it is very interesting because this S you can modify as a dl which is equal to r into theta. This r is what? A, so I will modify this as A. This O is the center, theta is this angle. Okay, now so if I substitute over here in this formula, and this r is also equal to what? A, so formula will become B is equal to mu naught upon 4 pi, it is I A theta upon A ka square. So 1A will get cancelled and I would left with B is equal to mu naught upon 4 pi, it is I theta upon A. So whenever we look the shape like this part of the circle, B is equal to mu naught upon 4 pi I theta upon what? A. Remember here, this theta and this sin theta is not the same. Okay, now because if we have learned about this dl is the small part. If I consider this as a very small part of the that is a dl, infinitesimally small, then this theta, dl and A, because according to Biot-Savart's law, the theta is the angle between dl and what the radius, that is the distance or the radius or whatever maybe it is, as a. Okay, so this theta is the angle between dl and that's why it is equal to 90 degree. So I hope it is clear, this formula and the shape. So if you want to note it down, you can note it down this. Okay, so next shape we are going to learn about. Fourth is now suppose the shape of the wire or coil is like this. In this case, let us imagine O is the center. Here in this case, the radius is R1. Here in this case, radius is what, the R2. Here is also R2 is greater than what, the R1. Now imagine, suppose in this direction the current is passing. In this direction the current is passing. The current is what, the R. Now again we will divide according to the rule. We will divide this entire shape into number of parts. Part number 1, part number 2, part number 3 and part number 4. From this part number 1 and part number 2, as we are having a very good knowledge about this, at point O it is never going to produce any kind of the magnetic field. Only we have to concentrate on the part number 2 and part number 3. What would be the magnetic field B2? B2 is equal to mu naught Ni upon what, the, as it is semicircle, it is 4a, so it is R1. Then B2 would be, that is B2, or if you want to consider B4 for this part. Okay, now this is B2, this is B4. For B4 it is mu naught N number of turns, current is the same, and it is 4 times of what, the R2 we have, okay, now denoted as radius. Now R and B, they are inversely proportional. So R2 is greater than R1. R2 is greater than what, R1. So we consider, that is R2 is greater, so B4 is smaller than what, B2. So total magnetic field, if we want to write it down, and naturally we have 3D imagination, look at this part, the current passing is in this manner. So magnetic field produced by the part number 2 as what, the B2. So the direction of B2 bar is out of the plane of this board. B4, this is B, okay, now this is B going to produce what, B4. Current is like this. In this manner the current is passing. Here the current is passing like this. Okay, now so B2 and here is what, B4. They both are in the same direction. So this is what, the B4 bar. Okay, so B2 bar and B4 bar, according to the direction wise, vector direction, they are in the same direction. So I will be writing total magnetic field as B2 plus what, B4, as they are in the same direction. So there is no need to decide who is greater, and that is because they can add up very easily. We will not much more think about the signs and the ijq. Now, so this magnetic field can be written as mu naught ni upon 4. Both are common. Mu naught ni upon 4. We can take it out common. It is 1 upon R1 plus 1 upon what, the R2. Now, dear student, you know this is out of the plane. If you resolve in terms of what, the ijk, so they are along what, the k, that is positive direction of the what, k. So it is k cap along the z axis, and this will be what, your the b bar. Remember here, if I resolve, if you're not understanding this, so I'll be drawing again for you here. So this is the okay now shape. If you resolve that shape like this, okay now. So this is along the same direction. Okay now, this is x-axis, y-axis, and what the z-axis. In this manner, you can imagine. It's a very good diagram for you. Okay now. So if you look this part and this k cap, and it is along what your the positive direction. Here is I cap, here is j cap, and here is what the k cap. In case suppose we were getting the opposite direction of the current, so both V2 bar and V4 bar will be inside the board, and in that case you would be getting what the minus of what the k cap. So dear student, this was a very interesting diagram and learning point for magnetic effect of electric current. Whenever in case of any MCQs, if they are asking in terms of magnitude, so we are ready for the magnitude. If they are asking in terms of what the IJK, so then also we can easily draw and we can easily get the answer for any type of what the MCQs. Okay now, so you may note it down.